Good morning, sir.
Good morning, sir. Good morning, sir.
Okay. So today we can start transmission media. So there are two types of transmission media: guided transmission media and unguided transmission media. Guided means physical transmission. Unguided means wireless transmission. Characteristics and quality determined by medium and signal. So main difference both wire and wireless transmission, it carries signal from one place to another place. So difference is quality and characteristics. So for guided, the medium is more important. For unguided, the bandwidth produced by the antenna is more important. So if it has higher bandwidth, it transmits more number of signals. In, physic, in physical transmission, Naveen, don't talk. So for guided transmission, the medium is more important. In which medium? Okay, there are different type of physical medium. So medium means it should transmit at the fastest rate. So there is a benefit in the physical transmission medium. For unguided, the bandwidth produced by the antenna is more important. Key concern are data rate and distance. How much distance we transmit a data. So what is the data rate? So these are the key concern in the transmissions. Okay, so there are two types of transmission media: guided and unguided. Guided means physical transmission and unguided means wireless transmissions. Next, design factor. Bandwidth means higher bandwidth gives higher data rate. Okay, more number of signal can be transmitted. Transmission impairments. Attenuation. Attenuation means loss of signal during transmission due to heat energy. Data signal, it can be corrupted. So attenuation means loss of energy. Interference, voice interference, electrical interference. Due to interference, signal may be lost, and due to heat energy, due to electrical interference, due to voice interference, data may be lost or corrupted. Number of receivers. In guided media, more receivers introduce more attenuations. Okay, so in guided media, so number of receiver also it is a one of the factor. Next, more receivers introduce more attenuation. So design factors, these are the factors: bandwidth, transmission impairment, interference, and a number of receivers. Next, electromagnetic spectrum. So these are due to there are different magnetic spectrum. Frequency heads 10 power 2, 10 power 3, 10 power 4, 10 power 5. So power from 10 power 0 to 10 power 4 ELF. That is a low frequency. Extremely low frequency. ELF means extremely low frequency. VF means voice frequency. So from 10 power 0 to 10 power 2, extremely low frequency. Up to 10 power 3, very voice frequency. Up to 10 power 4, there is a very low frequencies. So up to this frequency, power and telephone, rotating generator, musical instrument, voice microphones, these devices can be used. Okay, so that is the electromagnetic spectrum. From 10 power 4 to 10 power 9, radio and television, electronic tube, integrated circuit, cellular telephony. They can transmit a signal from at 10 power 4 to 10 power 9. Low frequency, medium MF, medium frequency, high HF, high frequency, VHF, very high frequency, okay, UHF, ultra high frequency. Okay, each wireless device, it can transmit at particular frequency. It can transmit signal from one place to another place at the particular signal. So from 10 power 0 to 10 power 4, normal transmission can be used. Telephone, power cable, generator, instrument, voice microphone, they can use up to 10 power 4, very low frequency. Okay, from 10 power 4 to 10 power 9, radio transmission, microwave transmissions, electric tube, cellular transmission are allowed. From 10 power 9 to 10 power 11, microwave, radar, microwave antenna, magnetars. Okay, 10 power 11 to 10 power 14, infrared, laser, guided missile, range finder. Each communication device, it transmit at the particular frequency only. At 10 power 15, visible light, that is optical fiber. So from 10 power 0 to 10 power 8, we can use twisted pair coaxial cable. From 10 power 3 to 10 power 9, coaxial cable is used. And 10 power 6 to 10 power 7, AM radio broadcasting device can be used. From 10 power 8 to 10 power 9, FM radio and television device can be used to transmit a signal. From 10 power 9 to 10 power 11, terrestrial and satellite transmission can be used. Okay, so these are the wavelength in space meter. Here 10 power 2, 10 power 3 means frequency, and here wavelength 10 power 6, 10 power 5, 10 power 4. At particular wavelength, data it can be transmitted. So there are three types of transmission media: twisted pair, coaxial cable, fiber optic cables. These guided means physical transmission, wired transmissions. There are three types of transmission: twisted pair, coaxial cable, and fiber optic cables. That is a characteristics of guided media: frequency range, typical attenuation, typical delay, and repeater spacing. Twisted pair with loading 0 to 3.5 kilohertz. It transmits signal up to 3.5 kilohertz frequency range. Attenuation 0.2 decibel per kilometer at 1 kilohertz, and typical delay 50 micron seconds per kilometer, and repeater spacing 2 kilometer. At every 2 kilometer a repeater is required. For twisted pair with loading, twisted pair multi-pair cables 0 to 1 megahertz, 0.7 decibel per kilometer at 1 kilohertz. Delay 5 microsecond per kilometer. Repeater 2 kilometer. So twisted pair for multiple pair cable is recommended to transmit a signal. Coaxial cable frequency range 0 to 500 megahertz. Up to this frequency range, data it can be transmitted. Typical attenuation 7 decibel per kilometer at 10 megahertz. Typical delay 4 microsecond per kilometer. 1 to 9 kilometer repeater spacing. Every 1 to 9 kilometer there is a repeater to regenerate a signal. Optical fiber or fiber optical cable. Frequency range 186 to 370 terahertz. Transmit a signal. Typical attenuation. So fiber optical fiber 186 to 370 terahertz, 0.2 to 0.5 decibel per kilometer, 5 microsecond per kilometer, 40 kilometer. Repeater spacing required at every 40 kilometer. So that is optical fibers. Transmission of, so that is the characteristics. So these characteristics range from different three types: frequency range, typical attenuation, typical delay, repeater spacing. First, twisted pair. So it is separately insulated. So twist per every 1 meter. Per every 1 meter. So it is cable, twisted pair cable, it will be twisted. So to avoid the interference, so the cable it will be twisted. Separately insulated. So insulated means it has two copper wire. Twisted pair cable, it has two copper cable. Two copper cable is insulated with plastic thin material, twisted together. often bundled into cables. So they are bundled into cables, usually installed in building during constructions. In early days, telecommunication department they use twisted pair cable. Okay, through twisted pair cable, telephones are connected. Telephone signals are transmitted from one subscriber to another subscriber. That is a twisted pair. And its applications. Most common medium, telephone network between house and local exchange. Okay, the twisted pair is a very easy to maintenance. Okay, at any time we can insert or at any time we can remove the cables in the telecommunication departments. So that is a common mediums. Telephone network between house and local exchange. That is subscriber loop. Within buildings to private branch exchange. So within building we can use it. Okay, or between house we can use twisted pair to transmit a analog signal. Twisted pair is transmit only analog signal, that is voice signal. For local area network at 10 Mbps or 100 Mbps, transmission speed 10 or 100 megabit per second. Advantage, okay, cheap. Twisted pair cable is very cheap and easy to work with cable, low data rate and short range. For short range we can use twisted pair cable. That is advantage and disadvantage. Short rate one, the data rate is very low and short range. Advantage, cheap and easy to work. Twisted pair transmission characteristics. Analog amplifiers every 5 kilometer to 6 kilometer. Digital use either analog or digital signal. Repeater every 2 kilometer or 3 kilometers. Okay, limited distance, limited bandwidth 1 megahertz, limited data rate. Only it accept data up to 100 megahertz. More than that, it will not accept. Susceptible to interference and noise. Okay, so it is subject to interference and noise. That is twisted pair. Okay, so interference are there and noise signal also there. Near end crosstalk, coupling of signal from one pair to another. So the crosstalk is available in twisted pair transmissions. We cannot avoid crosstalk. Coupling of signal from one pair to another. Coupling takes place when transmit signal entering the link couples back to receiving pair, and near transmitted signal is picked up by near receiving pair. So we have to maintain some distance. Otherwise, crosstalk it will we have to receive crosstalk. So there are two types of twisted pair: unsealed twisted pair and sealed twisted pair. So unsealed twisted pair, that is UTP, at both end are open. That is unsealed twisted pair. Ordinary telephone wire, cheapest, easiest to install, and suffers from external EM interference. External medium interference. Ordinary telephone wire, cheapest, easiest to install, suffer from external EM interference. That is UTP, unsealed twisted pair. and sealed twisted pair, metal braid or seating that reduces interference. In unsealed twisted pair STP, at one end is connected and at other end it will be open. That is UTP. In STP, that is in UTP unsealed twisted pair, at both end cables are open. So that is a difference between UTP and STP. Metal braided or sheathing that reduces interference. So there is a thick metal, that metal reduces, avoid the crosstalk, okay, and a more expensive, have harder to handle. So which is a thousand number of cables are bundled in a single sheath. So that is the harder to handle. Next, UTP categories. There are different category of UTP cables. Category 3, Category 4, Category 5, Category 6, Category 5E, Category 7s. Category 3 twisted pair up to 16 MHz. Voice grade found in most offices. Twist length of 7.5 centimeter to 10 centimeter. Category 4 up to 20 MHz. So there are different type of twisted pair. So one category 3 it is used for telephone system, and category 4 is 5, 6 they used for internet. Okay, so for different applications we can use different category of UTP cables. Category 3 up to 16 MHz. Voice grade found in most offices. Twist length of 7.5 centimeter to 10 centimeter. Category 4 up to 20 MHz. Category 5 up to 100 MHz. Commonly pre-installed in new office buildings. Twist length 0.6 centimeter to 0.85 centimeter. Category 5E enhanced, okay, category 6 and category 7. So these are different category of UTP cables are available for high data rate, for higher bandwidth we use category 6, category 7 UTP cable. For larger apartment we use category 6 and 7 UTP cable. Comparison of shielded and unshielded twisted pair. Okay, so frequency 1 megahertz. At 1 megahertz UTP category 3 is used. Okay, attenuation 2.6 decibel per 100 meter. Category 5 2.0 decibel and 1.1 decibel for 100 meters. And I think category 3 UTP, I think there is near end crosstalk 41, and category 5 62, 150 ohm STP 58, I think near end cross 58 decibel near end crosstalk. At 4 megahertz 5.6, 4.1 and 2.2 in category 3 5 ohm STP, and UTP 32 and UTP 5 53 and 150 ohm STP 58 decibel per 150 ohms and 16 megahertz. There are various ranges. 25 megahertz various range, 100 megahertz various range, 300 megahertz various range. So there is a comparison of shielded and unshielded twisted pairs. So UTP means unshielded, STP means shielded twisted pair. Next, bandwidth. 16 megahertz category 3, 100 megahertz category 5, 100 megahertz category 5E, category 6 200 megahertz, category 7 600 megahertz, cable type UTP, category 5 UTP FTP. UTP or FTP can be used. Category 5E UTP or FTP. Category 6 UTP or FTP. Category 7 that is M SSTP. Link cost CAT 5 is equal to 1. 0.7 category 3, 1 category 5, category 3 1.2, 1.5 category 6, category 7 2.2. So far we discussed twisted pair cable. Now we move to coaxial cables. A display comes. As student, display comes.
Yes, sir.
Okay. So first we discussed twisted pair cable. Next coaxial cable. So that is coaxial cable means it is used most probably in local area network and cable television network. In these two, these are the two applications for coaxial cable. Local area network or cable TV network. So that structure of coaxial cables. The first one is end view, okay, and the second one is side view. Outer sheath. The outer sheath means thick plastic sheet. Outer conductor. That is also copper cables. Insulations. So it will be insulated. Copper cable was insulated, and inner conductors. So these inner conductor, it can one is end view, another one is side view. Outer sheath, outer conductor, insulation, inner conduction. Outer conductor is braided sealed, and the inner conductor is solid metal. That is a metal cables, separated by insulating materials, covered by padding. Applications of coaxial cables. Most versatile mediums. Versatile medium means, so that is the telephone communication department, okay, communication device. So these are the most versatile medium. Television distribution, Airtel, aerial to TV, cable TV, okay, long distance telephone transmission can carry 10,000 voice calls simultaneously, being replaced by fiber optic. Coaxial cable is replaced by fiber optic cables. So for longer transmission, we can use either coaxial cable or optical fibers. Short distance computer system links for short communication, for short distance transmission, we use coaxial cables. Local area network. So the coaxial cable, it is the most versatile medium, television distribution, aerial to TV, cable TV. Right, okay, these are the applications of coaxial cables. Long distance telephone transmission can carry 10,000 voice calls simultaneously, being replaced by fiber optic. Short distance computer system link, local area network. So these are the applications of coaxial cable. Versatile medium, television distribution, and long distance telephone transmission, short distance computer system link, that is more modem, Wi-Fi, like that, local area network. Coaxial cable transmission characteristics: analog transmission, and it accepts both analog and digital transmission. Amplifiers every few kilometers, closer if higher frequency, up to 500 megahertz. So that is analog. So for analog signal, amplifier is required to regenerate a signal every few kilometers, and closer if for higher frequency. It is very closer for higher frequency. It can transmit up to 500 megahertz signals. Digital transmission, repeater is required for every 1 kilometer, closer for higher data rates. So both analog and digital transmissions are available in the coaxial cables. In twisted pair cable, analog transmission is only available. Okay, with the help of modem, digital transmission is available. So that is the difference between twisted pair and analog coaxial cables. Next, optical fibers, core, jacket, and claddings. Okay, so glass or plastic cores. So that is so here core means that is a thin glass fiber cable is made up of thin glass. Fiber cable is made up of thin glass. So that is core, glass core. And jacket. Okay, jacket means that is a protection. The plastic sheet, protected plastic sheet. Cladding, that is also a protected materials. So these are the outer protections, jacket and cladding. So glass or plastic cores, that is a cables. Here plastic or glass core, laser or light emit diode. So it accepts signal, light signal. So what kind of light signal? LED or laser light. Specially designed jacket, small size and weight. So it is small in size and weight. So next thing, fiber cable, it has two mode, single mode fiber and optical multi-mode fiber. Single mode and multi-mode. So in single mode means when light ray is transmit in a single medium, air to air, water to water. It transmit in single medium. It travel in single mode fiber. So when ray it transmit from one medium to another, from water to air or air to water. So it take different bounds. So that is a multi-mode. Multi-mode is required when light ray travel from one medium to another medium. Single mode is required when light ray travel in a single medium, air to air or water to water. So that is a two types of mode, single mode and multi-mode fiber are available. So there is an angle of incident, angle of reflection. So the right ray, it will be refracted at particular angle. and right ray is reflected at particular ray. So okay, beyond the angle, the ray, it will light ray, it will be reflected at particular angle, that right ray, it will be refracted. When light ray is entered from one medium to another medium, ray, it will be refracted. Okay, so light at less than critical angle is absorbed in jacket. So that is angle of incident, angle of reflections. So incident means when ray touches the boundary, that is incident. Reflection, okay, more than critical angle, it will be reflected. Ray, it will be reflected at the ray, it will be reflected at more than critical angles, more than 180-degree angles. That is benefits. Optical fiber benefit: greater capacity, data rates of hundreds of Gbps, smaller size and weight, lower attenuation, electromagnetic isolation, greater repeater spacing, 10 seconds of kilometer at least. So greater capacity, smaller size, lower attenuation, electromagnetic isolation, greater repeater spacing. So these are the benefits. In twisted pair and coaxial cable, attenuation is high. Here attenuation is low. So here it accepts electromagnetic signal is isolated. Okay, it accepts only light ray. So greater repeater spacing. Repeater spacing is greater, 10 seconds of kilometer. At least for every 10 seconds of kilometer, repeater spacing is required. Application of long haul trends, metropolitan trends, rural exchange trends, subscriber loops, LAN. So these are the fiber optic cables are used in this application. Long haul means STD or ISD. Metropolitan trunk. Metropolitan trunk means STD. Long haul means ISD. Rural exchange trunk. Subscriber loop, LAN. Optical fiber transmission characteristics: act as wave guide for 10 power 14 to 10 power 15 Hz, portions of infrared and visible spectrum, light emitting diode, LED, cheaper, wider operating temp range, last longer, injection laser diode, ILD, more efficient, greater data rate, wavelength division multiplexing. Okay, so these are the characteristics of fiber optics. Act as waveguide for 10 power 14 to 10 power 15 Hz. And it accepts LED, light emitting diode. It is cheaper, wider operating temp range, last longer. Injection laser diode, ILD, more efficient, greater data rate. Wavelength division multiplexing. For wavelength also, fiber optic cable is used. That is a step index multi-mode, graded index multi-mode, single mode. As I told, that is it travel in a same medium, air to air. Graded index, okay, it will take different bounds. It will take different bounds. In multi-mode, two types, step index and graded index. Okay, it will take different bounds. Output pulse, output pulse. That is mode of fiber optical. Frequency utilization for fiber application. Wavelength in vacuum range 820 to 900. Frequency range 366 to 333. Fiber type multi-mode. Application local area network. For local area network, we use multimode fiber. Wavelength 1280, 1282, 1350. Frequency range 234 to 222. Band label S. Single mode various. 1528 to 1561. 196 to 192. Band label C. Single mode WDM. 1561 to 1620. Frequency range 185 to 192. Band label L. Single mode WDM. Wavelength division multiplexing. So here a single mode fiber is used for wavelength division multiplexing and various application. Local area network multimode fiber is used. So these are the frequency graph, twisted pair graph, how it will transmit a data, and wavelength in vacuum, and a frequency coaxial cable transmission, and composite graph. Okay. So far we discussed physical transmission medium. Next, wireless transmission mediums. So all of you listening?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Wireless transmission frequencies 2 gigahertz to 40 gigahertz. Its transmission speed from 2 gigahertz to 40 gigahertz. Microwave, highly directional, point to point. Satellite, 30 megahertz to 1 gigahertz. Omnidirectional, broadcast radio, 3 into 10 power 11 to 2 into 10 power 14. Infrared, local. Okay, so wireless transmission frequencies 2 gigahertz to 40 gigahertz. So at this speed, microwave, highly directional, point to point satellite can be used. From 30 megahertz to 1 gigahertz, radio broadcasting, it can be used. And 3 to 10 power 11 to 2 into 10 power 14, infrared and locals. These are the different wireless transmissions are possible at different frequencies. Antennas, electrical conductor used to radiate electromagnetic energy or collect electromagnetic energy. So we used antennas in the top of the building. Why we use antenna? To receive electromagnetic signal at particular directions. At particular direction, we can receive electromagnetic signals. So through antenna, the signals it will be received and sent to the via cable to televisions. So 20 or 25 years back, in each house there is a antenna. Through antenna only, signal it will be absorbed and sent via cable to televisions. Okay, so nowadays satellite dish antennas are available. Okay, through this antennas, it captures signal and sent to the television through cables. There is no need of a separate antenna for every house. So through this antenna, It will send to the server. From server, it goes to every house. So electrical antenna means electrical conductor used to radiate electromagnetic energy. It will radiate electromagnetic energy or send or collect electromagnetic energy. Transmission, radio frequency energy from transmitter converted to electromagnetic energy by antenna, radiated into surrounding environment. So through antenna, the radio frequency energy from transmitter. Okay, from transmitter it will accept and converted to electromagnetic energy. Radio signal converted into electromagnetic energy, and through antenna radiated into surrounding environment. Reception, electromagnetic energy impinging on antenna converted to radio frequency electrical energy fed to receivers. Same antenna often used for both. So we can use a transmitter. That transmitter it able to transmit or accept a signals, electromagnetic signals. Radiation pattern, power radiated in all directions, not same performance in all directions. Isotropic antenna is point in space, radiates in all directions equally, gives spherical radiation pattern. Parabolic reflective antenna. So in wireless transmission, we use different antenna to send a signal or receive a signal. So the previous one, radiation pattern, power radiated in all direction, not same performance in all direction, isotropic antenna. Okay, and now parabolic reflective antenna used for terrestrial and satellite microwave. So we use terrestrial communication and satellite communication. Parabola is locus of point and equidistance from a line and a point not on that line. Fixed point is focus. Line is directrix. That is parabola. So parabola is locus of point equidistance. At particular point, it will be at equal distance. A signal it will be transmitted from line and a point not on that line, from one line to another one. Revolve parabola about axis to get paraboloid. Cross section parallel to axis gives parabola. Cross section perpendicular to axis gives circle. Sources placed at focus will produce waves reflected from parabola in parallel to axis. Creates parallel beam of light, sound, radio. On reception, a signal is concentrated at focus where the detector is placed. So there is a pattern of parabolic dish antenna. So that is a structure, parabolic structure. So direction, so it is reflected in on that line, okay, the parabola. And the second one, cross section of parabolic antenna showing reflective property. Antenna gain, measure of directionality of antenna. Power output in particular direction compared with that produced by isotropic antenna, measured in decibels, results in loss in power in another direction. Effective area relates to size and shape. So these are the gains. So what is the gain of antenna? So directionality, we can measure the directions from which direction a signal is received. Power output in particular direction compared with that produced by isotropic antenna. That we can input power. Power output should be put. Okay, from received from isotropic antenna. The signal it will be measured in decibels. results in loss in power in another direction. So it will be sometimes it will be loss. Effective area relates to size and shape. In wireless transmission, we use terrestrial microwave. So this terrestrial microwave, it uses parabolic dish, focused beam, line of sight, long haul telecommunication, higher frequency, give higher data rates. These are different way of transmitting a signal in microwave transmission. So through parabolic dish, it can transmit a signal, or focused beam, or line of sight, or long haul telecommunication, long distance telecommunication, or higher frequency, give higher data rate. Second one, satellite microwave. Satellite is relay station. Satellite is a relay station. Satellite receives on one frequency, amplifies or repeats signal and transmit on another frequencies. So that is a characteristic of satellite. It receives on one frequency and transmit in another frequencies. Required geostationary orbit, height of 35,784 kilometer. Television, long distance telephone calls and private business network. These are the applications of satellite. Transmit television broadcasting, long distance telephone and private business network. For these application, we use satellite microwave. Point to point links. So Earth station, from Earth station, signal is sent to the satellite. From the satellite, it accepts in one frequency and send on another frequency to the Earth stations. So here, to Earth station, it will not directly communicate. Through satellite, it send or receive a signal. That is point to point link. That is broadcast link. A multiple receiver, one sender, one transmitter and multiple receivers. So from one station, signal is sent to the satellite antenna, and that satellite send a signal to multiple stations. That is one sender, multiple receiver. That is a broadcast link. This is point to point. The two station, it can communicate through satellite, point to point. Here, a broadcast link, one sender and multiple receiver. Radio broadcasting. Radio broadcasting is omnidirectional. Okay, and it is used for FM radio. It uses UH, ultra high frequency and very high frequency television network. Line of sight suffers from multi-path interference, reflections. Modulate non-coherent infrared light, line of sight or reflection blocked by walls. Example, TV remote control, IRD port. TV remote control, IRD port are used for infrared communications. Line of sight blocked by wall, modulate non-coherent infrared light. Wireless propagation. Signal travels along three routes. Ground wave follows contour of Earth up to 2 MHz AM radio, sky wave, amateur radio, BBC World Service, Voice of America, signal reflected from ionosphere, layer of upper atmosphere, actually refracted, line of sight above 30 megahertz, may be further than optical line of sight due to refraction more later. So ground wave, sky wave, line of sight. So that is signal travel along three routes. It routes via ground wave, follows contour of earth up to 2 megahertz AM radio, or it takes sky wave, amateur radio, BBC, World Service, Voice of America. They use sky wave signal reflected from ionosphere layer of upper atmosphere, and a line of sight from one direction to another direction. That is line of sight. Okay, one building to another building, one area to another area. That is line of sight above 30 megahertz. Maybe further than optical line of sight due to refraction. More ground, ground wave propagation, signal transmit antenna and receiving antenna. That is ground wave. To transmit a signal at every 50 kilometer, we establish a tower. From one tower to another tower, signal it will be propagated at below 2 megahertz. If signal it will be transmitted below 2 megahertz, we use tower to tower transmissions. This is ground wave propagation. Next, sky wave propagation. So there is ionospheres. So from transmitting antenna, signal sent to ionosphere. Then it will be propagated to earth. Then it will be sent to sky. So before reaching to another tower, it will go and come. It will send and receive from ionosphere. Then finally it will reach to receiving antenna. Okay, so from one tower to another tower, there is no direct communication. So through ionosphere, signal it will be communicated from one tower to another tower. So the propagation speed 2 to 30 megahertz. This is sky wave. Another one, line of sight, from directly from one tower to another tower, signal it will be transmitted. So there is a transmitter and there is a receiver. Okay, through transmitter signal it will be sent. Through receiver at the other end it will be received. That is line of sight propagation. Refractions. Velocity of electromagnetic wave is a function of density of material, 3 into 10 power 8 meter per second in vacuum, less in anything else. As wave moves from one medium to another, its speed changes. Index of refractions. Sin, angle of incidence, sin, angle of refraction. Okay, and varies with wavelength. May cause sudden change of direction at transition between media. May cause gradual bending if medium density is varying. Density of atmosphere decreases with height, results in bending towards earth of radio waves. So signal is refracted. How it will be refracted? Velocity of electromagnetic wave is a function of density of material. 3 into 10 power 8 meter per second in vacuum. It will be refracted. As wave moves from one medium to another, its speed changes. Index of refractions. Okay, that is refractive index. Sin, angle of incidence, divided by sin, angle of refraction, varies with wavelength. May cause sudden change of direction at transition between media. may cause gradual bending if medium density is varying. Density of atmosphere decreases with height, results in bending towards earth of radio waves. Optical and radio horizons. Okay, optical horizons, that is earth. Optical means there is a fiber transmissions, fiber optical transmission, light wave transmissions. Radio horizon means electromagnetic signal, electromagnetic signals. Another one, line of sight transmissions. So far we discussed microwave transmission, satellite transmission, radio transmission. Another transmission, line of sight transmission, free space loss. There is no free space. Signal disperses with distance greater for lower frequencies. Atmospheric absorption. Water vapor and oxygen absorb radio signal. Water greatest at 22 GHz, less below 15 GHz. Oxygen greater at 60 GHz, less below 30 GHz. Rain and fog scatter radio waves. Multipath. Better to get line of sight if possible. Signal can be reflected, causing multiple copies to be received. Maybe no direct signal at all. May reinforce or cancel direct signals. Refraction may result in partial or total loss of signal at receivers. So for this transmission, we need atmospheric absorption, we need multipath, we need refraction and free space loss. So these are the characteristics of line of sight transmission. So the traveling at distance map. At one side, y-axis loss decibel, 60, 70, 30, and distance 5 kilometer, 10 kilometer, 50 kilometer. At how many speed it will be traveled. At how many speed it will be traveled. (300 gigahertz from 140 decibel and 10 kilometers. 30 gigahertz, okay, 5 to 10 kilometers. 120 decibels. 300 megahertz speed, 10 kilometers at 80 decibels. The distance, x-axis is the distance and the y-axis is loss, let's say in decibel. Multipath interference, microwave, line of sight, and mobile radio. These are the mobile radio. So there is a mobile tower, apartment, and buildings. So from your car, he call a person through mobile network. The call is sent to mobile tower, and again it will reach to exchange. Then it comes to car, again it goes to a buildings. So there is a mobile radio communication. This is first one is a microwave radio communication. So this chapter is over. Transmission media chapter is over.
சூப்பர் மார்க் அதான் போட்டு
Okay, next piggybacking. Next chapter, sliding window protocols. Sliding window protocol. So we use piggybacking method. So what is mean by piggybacking method? Piggybacking means on the bag, okay, back side. So we can pull one bag, piggybacking. So in most practical situation, there is a need of transmitting data in both direction. In both direction, we can transmit a data. This can be achieved by full duplex transmission. Full duplex means when station A sending a data to station B, at the same time station B also sending a data to station A. That is full duplex transmission. At both side station sending a data. If this is done, we have two separate physical circuit, each with forward and reverse channel. For full duplex, we need two separate cable or channel. In both cases, the reverse channel is almost wasted. To overcome this problem, a technique called piggybacking is used. The technique of temporarily delaying outgoing acknowledgement so that they can be hooked onto the next outgoing data frame is known as piggybacking. For example, A is sending a data to B. Okay, B it also want to send a data and also send acknowledgement. Okay, along with data, acknowledgement signal for previous one is also sent. Okay, so along with data, okay, along with data, that acknowledgement signal also it will be sent, acknowledgement data for previous one. Okay, both current data and the previous acknowledgement both are sent. That is called a piggybacking. So that technique of temporarily delaying outgoing acknowledgement. Okay, technique of temporarily delaying outgoing acknowledgement so that they can be hooked onto the next outgoing data frame is known as piggybacking. However, piggybacking introduces a complication not present with separate acknowledgements. Okay, introduces a complication not present with separate acknowledgement. How long should the data link layer wait longer than the sender's time period? Okay, so this data link layer it uses this one piggybacking method. The frame will be retransmitted, defeating the whole purpose of having acknowledgement. Of course, the data link layer cannot foretell the futures, so it must resort to same ad hoc scene, such as waiting a fixed number of milliseconds. If a new packet arrives quickly, the acknowledgement is piggybacked onto it. Otherwise, if no new packet has arrived by end of this time period, the data link layer just send a separate acknowledgement frames. If there is no data frame, that data link layer it send a acknowledgement frame separately. Okay, this is called piggybacking. Next, sliding window protocol. So what is mean by sliding window protocol? In all sliding window protocol, each outbound frame contains a sequence number. But every outgoing frame, it has sequence number. Okay, from 0 to some maximum, 0 to 99, 0 to 49, like that. The maximum is usually 2 power n minus 1. So n is there is a 100. N is 100 means 2 power 100 minus 1. Okay, so maximum is 2 power n minus 1. So the sequence number fits nicely in an n bit field. The stop and wait sliding window protocol uses n is equal to 1, restricting the sequence number to 0 and 1s. So more sophisticated version can use arbitrary n's. Here in sliding window protocol, so there is one stop and wait protocol. So it will sending a data, that is it will stop, okay, and wait. So after receiving the signal, after receiving acknowledgement signal, it will send another data frame, that is called a stop and wait protocols. So the essence of all sliding window protocol is that at any instant of time, the sender maintains a set of sequence number corresponding to frame it is permitted to send. These frames are said to fall within sliding window. Similarly, the receiver also maintains a receiver window corresponding to the set of frames it is permitted to accept. The sender's window and receiver window need not have the same lower and upper limit. The sender window and receiver window need not have lower and upper limit, even have the same size. In some protocol they are fixed in size, but in other they can grow or shrink as frames are sent and received. So here when we send a data frame to receivers, it has no upper and receiver upper limit and lower limit. So if they wish, it can send any number of data. So they are fixed in size. Each packet or each data frame 10 bytes or 10 kilobytes. Okay, so in the same fixed number of packet, it will send to the receivers. The sequence number with in the sender's window represent frames sent but as yet not acknowledged. The sequence numbers within the sender's window represent frames sent but as yet not acknowledged. Whenever a new packet arrives from the network layer, it is given the next highest sequence number, and the upper edge of the window is advanced by 1. When an acknowledgement comes in, the lower edge is advanced by 1 step. So the sequence number with the sender's window represent frame sent but as yet not acknowledged. For a sequence number 1, there is a data frame. It is a sequence number 1. It's sent to the receiver, but it is not acknowledged. So whenever a new packet arrives from the network layer, it is given the next highest sequence number, and the upper edge of the window is advanced by 1. So when an acknowledgement comes in, the lower edge is advanced by the 1. So for example, so data frame 10 is sent. Okay, so once data frame is sent to 1, next data frame 9 it should be received. Then data frame 8 should be received. Then data frame 7 it should be received. Like that, it will send to the sender to receivers. So that is a sender and receivers. This is sender That is it start from 0 to 1 receiver. Okay, here also same that 0 to 1. Here 1, then 1 to 2. Okay, then 1 to 3. Like that. Every time it send one data frames. Okay, after 10 minutes we meet, we can start, we continue the network classes. You take 10 minutes break. Okay, hello students, we take break.
Okay, sir. Okay, sir.
Okay, sir.
Okay, sir. Okay, sir. Yes, sir. Yes, sir.
Okay. Next time, medium access control sublayer. Networks can be categorized in two ways, point to point and broadcast channel. So point to point network and broadcast network, already you know. Point to point network, one system directly send a data to another system through single cables. Between two pair of system, there is a cable. Through cable, data will be transmitted point to point. Broadcast channel means that in multiple systems, it will be connected through single cable. Multiple systems are connected through single cables. If one station sending a data, all other system receive a data. That is broadcasting. In broadcast network, the key issue is how to share the channel among several users. More than one user want to occupy the channel or cables. How to share? That is a key issue in the broadcast channel. Example, a conference call with 5 people. Broadcast channels are also called as multi-access channel or random access channel. Okay, so the broadcast channel is called random access or multi-access channel. Multi-access channel belong to a sub-layer at the data link layer called MAC sub-layer. Multi-access channel belong to a sub-layer that in data link layer which is called MAC, medium access sub-layer. Medium access controller sub-layers. So the channel allocation problems. So the MAC sub-layer, it resolved the channel allocation problem. Static channel allocation in local area network and metropolitan area network. Dynamic channel allocation, pure aloha and slotted aloha. Okay, and CSMA. These are the channel allocation method, FDM and TDMs. So the drawback, channel is wasted if one or more stations do not send data. In static channel allocation, channel allocation is wasted if one or more stations want to transmit a data. Okay, if users increases, this will not support it. If number of users is increased, static channel, it will not be supported. That is a drawback. Next, dynamic channel allocations. Pure aloha and slotted aloha. Pure aloha and slotted aloha. And then CSMA. CSMA 21. CSMA CD. Collision reduction. CSMA collision access. There is two method in CSMA. So that is two way of dynamic channel allocations. First, discuss pure aloha method. In 1970s, Norman Abramson and his colleagues devised this method. Norman Abramson devised this method, used ground-based radio broadcasting. This is called the Aloha system. The basic idea, many users are competing for the use of single shared channel. There are two versions of Aloha, pure and slotted. There are two Aloha protocol, pure Aloha and slotted Aloha. What is Aloha system? Using of ground-based radio broadcasting. To send a channel, to transmit a channel, it uses radio-based broadcasting. That is called a Aloha systems. In Aloha, two protocol, pure Aloha, slotted Aloha. Pure Aloha, okay, so that is pure Aloha does not require global time synchronization, whereas in slotted Aloha, the time is divided into discrete slot into which all frame must fit. So in pure Aloha, no time synchronization, as it is it transmitting a data. But in slotted Aloha, each station it get time slot. When it slot comes, it's transmitting a data. So let users transmit whenever they have data to be sent. Okay.
சார் ஆடியோ மியூட் ஆயிடுச்சு சார்.
Okay. So Aloha system means it is a ground-based transmitting, ground-based broadcast, radio broadcasting. That is Aloha system. Aloha system, it transmit data using radio broadcasting. It uses two protocol: pure Aloha, slotted Aloha. Pure Aloha, it will not follow time synchronization. As it has data, okay, it can transmit a data. It whenever it has data, it transmit it. That is pure Aloha. But slotted Aloha, each user or station, it has assigned a time frame. When time comes, okay, there's a user sending a data. Okay, so not all the data. Whenever they have data, it cannot send. Okay, when the time comes, they send a data. That is slotted Aloha. Okay, you can difference. You know difference between pure and slotted Aloha. Pure Aloha, whenever they have data, it can send. Slotted Aloha, when time comes, it's sending a data. Okay, to avoid a collisions. Let users transmit whenever they have data to be sent. There will be collision and collided frames will be damaged. So if the data is collided, the collided frame, it will be damaged. Senders will know through feedback property whether the frame is destroyed or not by listening a channels. Before sending a data, sender know, okay, the channels. Okay, it will observe, listen the channel whether the channel is free or busy. With a land, it is immediate. With a satellite, it will take 270 meter per second. If the frame was destroyed, the sender wait a random amount of time and again sends the frame. If the frame was destroyed, the sender waits random amount of time and again it sends. Okay, the waiting time must be random, otherwise the frame will collide over and over. So here user A, B, C, D. In user A, there is user A sending a data frame, user B sending a data frame, C sending a frame, D sending a frame. So once the before reaching a station, the B is sending another data. Before reaching another, C is sending a data, and D is also sending a data. Frames are transmitted at completely arbitrary times. Okay, at discrete intervals, frames are sent. At discrete intervals, frames are sent. Whenever two frames try to occupy the channel at the same time, there will be a collision and both will be destroyed. When two stations is sending a data frame in the same single channel, both are collided, okay, and destroyed. We have to find out what is the efficiency of Aloha channel. Let us consider an infinite collection of interactive users sitting at their system. A user will always in two states, typing or waiting. In a system, user have two states, typing state or waiting state. Let the frame time denotes the time required to transmit one fixed length frame. Assume that infinite population of users are generating a new frame according to the position distribution with mean n frame per time. If n greater than 1, number of users greater than 1 user are generating frame at higher data rate than channel can handle. Okay, so if n greater than 1 means users or generating frame at higher rate than channel can handle. Okay, for reasonable throughput 0 less than n less than 1. Number of users between 0 and 1. In addition to new frame, the station also generate retransmission of frames, old and new frame, or G per frame time. G greater than or equal to n. What is mean be that is old and new frame or G per frame. At low load there will be few collisions. S equal to G is approximately to N. Under all loads, at low load, G approximately N. At under all loads, the throughput S is equal to GP. PS is equal to GP naught. P naught is the probability that frame does not suffer a collision. A frame will not suffer a collision if no other frame are sent with one frame time of its sort. So, after some interval, every station has some time sending a data frame. If it follows, no frame will be collided. A sending a data. After reaching a frame, B is sending a data. After the B frame sent, reached the C, it can send it. So in this order, no collision will happen. A frame will not suffer a collision. It will not suffer a collision if no other frame are sent with one frame time of its start. Here, let T be the time required to send a frame. T is a time required to send a frame. If any other user has generated a frame between time T0 and T0 plus T, the end of frame will collide with the beginning of the shaded frame. Okay, so between frame time T0 and T0 plus T, the T frame will send at T0 time. So another frame will send T0 plus T. Similarly, any other frame between T0 plus T and T0 plus 2T will bump into the end of the shaded frames. Okay, so the probability K frame are generated during the given frame time is given by Poisson distributions. P or K is equal to GK e power minus G, K factorials. Okay, so the probability of 0 frame is just e power G. In an interval 2 frames time long, the mean number at frame generated is 2G. The probability at no other traffic being initiated during the entire vulnerable period is given by P naught equal to E minus 2G. Where we got e power minus 2G by using Pk G power K e power minus G. Using this formula, we can get P naught Poisson distribution e power 2G to sending a data with probability of no collisions. The maximum throughput occurs at G is equal to 0.5 with S power 1 by 2 E is equal to 0.184. So that is the Piraloha method. Here, first frame it send, okay, that is a first frame, and the next frame T0 plus T, T0 plus 2T collide with the start of this shaded frame, collide with the end of the shaded frame. Okay, so start of the second frame, end of the first frame, both are collided. This is end portion, this is first portion. Okay, the collide with the start of the shaded frame, both are collided. So there is a time taken 2 0 plus T and 2 0 plus 2T. There is graph map, throughput versus offered traffic for Aloha system. For pure Aloha, S is equal to G e power minus G. Okay, so that is S throughput per frame time 0.18 seconds. G atoms per packet time. This is x-axis atom per packet time, y-axis throughput from frame time packet time 0.5. At 0.5, okay, it will be bend in pure Aloha. In slotted Aloha 0.36, it will be bend. It will be bend. That is comparison between pure and slotted Aloha. Next, slotted Aloha. So far we discussed pure Aloha. Now we discuss slotted Aloha. In 1972, Roberts devised a method. Devised means find out. Devised a method for dubbing the capacity of Aloha distance. In this system, the time is divided into discrete intervals. The time is divided into discrete intervals with each of the wave. In each interval corresponding to one frames. One way to achieve synchronization would be to have to one special station emit a pip at the start of each interval with a clock. In Robert method, which has come to know that as slotted Aloha in contrast to Abraham's plot Aloha, pure Aloha, a computer is not permitted to send whenever a carriage return is typed. Computer is not permitted to send whenever a carriage returns is typed. So instead, it is required to wait for the beginning of the next slot. So when we send one load of lorry, okay, after unloading, it should reach the starting place. Again, it has to load and reach the receiving end. So this method is not obviously for pure Aloha. Slotted Aloha only it will take care. Instead, it is required to wait for beginning of the next slot. Thus, the continuous pure Aloha is turned into a discrete one. Since the vulnerable period is now halved, there are no other traffic during the same slot as our test frame is e power minus g, which leads to S is equal to g power g into e power minus g. At g is equal to 1, slotted Aloha will have maximum throughput. So S is equal to 1 by e or about 0.356, twice of pure Aloha. So now we discuss the slotted Aloha. First pure Aloha we discussed. Now slotted Aloha. In slotted Aloha, so the per second Gs is equal to G into e power minus g. Next topic, carrier sense multiple access protocol. Protocol in which station listen for a carrier and act accordingly are called carrier sense protocols. So to send or to receive, we use protocols. Okay, before sending a data, user must watch or listen the computer. Okay, so if channel is free, it transmits a data. If channel is busy, it wait until the previous one is completed. So that is the carrier sense multiple access protocols. When first one persistent CSMA protocol. When a station has data to send, when station has a data, it is listen to channel if anyone else transmitting at the moment. If the channel is busy, the station waits until it becomes ideal. The channel is busy. Channel means cable. The station waits until they become data. So when the station detects an ideal channel, it transmits a frame. If the cable is no user occupy the cable or transmit a data. So another station, they will detect the channel and transmit a frame. If a collision occurs, the station waits a random amount of time and starts the over again. The protocol is called one persistent, also because the station transmits with probability of 1 when it finds the channel ideal. So if channel is ideal, it's sending a transmitted data to the receiver. If channel is busy, user or station has to wait till the previous one is completed. The propagation delay has an input effect on the performance of the protocol. The longer the propagation delay, the worse and the performance of the protocols. Even if the propagation delay is 0, there will be collisions. If two stations listen the carrier, if two stations listen the channel that is ideal the same, both will send frame and there will be a collisions. So next, first one, persistent protocol. In persistent protocols, we use if two channel listen the channel that is ideal the same, both will send frame and there will be collisions. Non-persistent CSMA. In this, before sending a station, sends the channel. Here station listen the channel or sends the channel. If no one else is sending, the station begins doing so itself. If no one else is sending, the station is sending a data. However, if the channel is busy, the station does not continually sends it, but it waits random amount of time and repeat the process. This algorithm leads to better channel utilization, but longer delays than one persistence. So one persistent means if no one is sending, it starts data or frame to communication lines. If everyone is in communication line, it will be more if no one else is sending, the station begin doing itself. If channel is busy, the station does not continually senses, but it waits a random amount of time, then repeat the process. If channel is busy, the station it wait and for the particular time and then repeat the process. This algorithm leads to better channel allocation but longer delays than one persistent calls. Okay, why with persistent CSMA, what happens if two channels become active when the third is busy? Both wait for the action station to finish, then simultaneously launch a packet resulting collision. There are two ways to handle this problem. P persistent CSMA. The first technique is for waiting station not to launch a packet immediately when the channel becomes ideal. First lost coin and send packet only if the coin comes up heads. If the coin comes up tails, if coins come up heads, okay, it send a packet. If coin comes up tails, the station wait for some time, then repeat the process. The idea that if two stations are both waiting for the this reduces the chance of collision from 100% to 25%. So if two stations are both waiting for the medium, so it reduces the chance of collision from 100% to 25%. A simple generalization of the scheme is to use a biased coin so that the probability of sending a packet when the medium becomes ideal is not 0.5, okay, but p where 0 less than p less than 1. We call such a scheme p persistent CSMA. The original scheme where p is equal to 1, that's called 1 persistent CSMA. So first we use one persistent protocol, persistent CSMA, non-persistent CMA. Then now we use P persistent CSMA. The first technique is for waiting station not to launch a packet immediately when the channel becomes ideal. Okay, but first toss a coin and send a packet only if the coin comes up heads. So if the coin comes up tails, the station wait for some time, okay, then repeat the process. So the idea is that if two stations are both waiting for the medium, this reduces the chance of collision from 100 pixel to 225 pixel. A single generalization, a simple generalization of scheme is to use a biased coin so that the probability of sending a packet when the medium becomes free is not 0.5 but p where 0 less than p less than 1. We call such a scheme P persistent CSMA. So there are three types: P persistent CMA, CSMA CD, CSMA CA. So far we discussed non-persistent CMA, P-persistent CMA, one-persistent CMA. So what is mean by non-persistent CSMA? If channel is busy, the station does not continually sends, but it won't wait random amount of time. Repeat the process. If no one else is sending, the station begins doing so itself. Next is CSMA CA. What is mean by CSMA CA? It many wireless LANs, unlike wires LANs, either it is wired or wireless. The station has no idea whether the packet collided with another packet. So we will not bother about collision data, okay, until it receive acknowledgement from receiver. In this situation, collisions have a greater effect on performance than with CSMA CD, where avoid collisions. If possible, CSMA CA is basically persistent with the twist, and then where colliding packets can be quickly detected and aborted. So once the packet or frame is collided, it will be detected and it will be aborted. So it makes sense to try to avoid collisions. If possible, CSMA CA is persistence with the twist that when the medium becomes ideal, the station must wait for time called the infraline spacing or IFS before contending for a slot. A station gets a higher priority. It is allocated and it is allocated smaller inter-frame spacing. When a station wants to transmit data, it first checks if the medium is busy. If it is, it continuously senses medium, waiting for to become data. When the medium becomes ideal, the station first wait for interference spacing corresponding to formerly to its priority level, then sets contention timer to a time interval randomly selected in the range. Next, collision free protocols. First one, bitmap protocols. So last one we discussed collision access. Now we use collision free protocols, bitmap protocols. In the basic bitmap method, each contention period consists of exactly n slot. Each period contains n slot. If station 0 has a frame to send, it transmits 1 bit during 0 slot. Okay, so no other station is allowed to transmit during this slot. Regardless of what station 0 does, station 1 get the opportunity to transmit a 1 bit. Okay, so if any one station sending a data, and all other stations should wait. Okay, according to this time slot, it should sending a data. So that is the bitmap protocols. Here you see 0, 1, 2, 3, 4, 5, 6, 7, 8 contention slot. Okay, at 3, at 5, there will be a 1 bit. Frames 1 to 1, 3. Okay, and 8 contention slot. User 3 and user 7, it's sending a data. Okay, so among others, among 5, only 2 stations it's sending a data. The first 3 it's sending a data, then 7 it's sending a data. This is 1-bit protocols. Next, basic bitmap protocols. Since everyone agrees on who goes next, there will never be any collisions. So among multiple users, they have come to common agreement. Who goes next? Who go now? Okay. So after the last ready station has transmitted its frame, and even all stations can easily monitor. Another n-bit contention period is begins. If station becomes ready just after its bit slot has passed by, it is out of luck must remain silent until every station has had chance and bitmap has come around again. So if station ready, its bit slot has passed. If station send is ready, it bit is passed. And sometimes every station has a chance and transmit a data. This is basic bitmap protocols. Next, binary countdown. A problem with the basic bitmap protocol is that the overhead has 1 bit per station. A station waiting to use the channel now broadcast its address as binary bit sharing. So in binary countdown method, so a user depends on the administrator or lab in charge. He should depend. So you have station waiting to use a channel new broadcast address as a binary string. If station want to sending a data to more than one person, he need address. After that, he only transmit a data. All addresses are assumed to be the same length. All addresses must assume same length. The bits in each address position from these different stations are Boolean or together. So bitmap protocol and binary countdowns. This is 00010 0123 bit time. Okay, 010 1001 1010 result. So you transmit 0123. It transmit 0100 0001 like this. Next thing, Ethernet. So there are two types. Baseband Ethernet, baseband for digital transmitter, broadband Ethernet for analog transmission. So there is a project IEEE at 802. It has 16 models are available. Out of 16 model, one module it takes. So here Ethernet is used in the local area network. Through Ethernet, all the computers are connected. 10 base 5, 10 base 2, 10 base T, 10 base 5, 10 base T. Okay. Next, in project 802.3, cabling. 5 types of cabling are commonly used. 10 base 5 cabling called thick Ethernet came first. 10 base 5 came first. It resembles a yellow garden house with markings every 2.5 meter to show whether the taps go. Connections to it are generally made using vampire caps, in which a pin is capsularly forced halfway into several coaxial cable core. The notation 10 base 5 means that it operates 100 MHz, uses baseband signaling and can support segment of up to 500 meter. So 10 base 5 cable thick coax, maximum segment 500 meter, nodes 100 nodes, good for backbone. 10 base 2 thick So here 10 base 5 means baseband broadcasting, digital broadcasting, 10 megabit per seconds, and 5 means it supports segment up to 500 meter. 5 means 500 meter. The second cable type was 10 base 2 or thin Ethernet. 10 base 5 is thick Ethernet. 10 base 5 is thin Ethernet. In contrast to the Gordonic host like thick Ethernet bends easily. Connections to it made using industry standard BNC connectors to form T junction rather than using vampire tabs. 10 base 5 thick coax, good for backbone. 10 base 2 thin coax, cheapest system. 10 base T twisted pair. 10 base F fiber optics. Next. 10.23 max sublayer protocol. Previous one 10.2.2, now 10.2.3 preambles. This is Manchester encoding and differential Manchester encoding. Bit stream 101001. For this one, there is at Manchester encodings. Okay, 1 means that is low to high. 0 that is at 0 to low to high. 0 low to high. High 1. Here low to high, low to high, low to high. So 1 to high means it will be set Manchester. Differential Manchester codings. Transition here indicates at 0. Transition at 0. Lacks of attention here indicates once. Lack of transition here indicates at once. There is a comparison table between bit stream 1 corresponding signal and 0, that is 0 0. Okay. Another one, the 802.3 max sublayer protocols. Preamble. Each frame start with a preambles. Each frame start with a preamble of 7 bytes, each containing a bit pattern 10101010. Start of frame byte. It denotes the start of the frame itself. It contains 10101011. Preamble. Bit pattern 10101010. Start of frame byte 1010 and last 11. destination address. This gives the destination address. The higher order bit is 0 for ordinary address, and for one bit 1 for group address. Multicasting. All bits are ones in the destination field frame will be delivered to all stations. The 46th bit is used to distinguish local from global addresses. Length field. First one, preamble 7 bytes, start of frame by 1010, destination address. The higher order bit is 0 for ordinary address and 1 for group address. Length field. This tells how many bytes are present in the data field from 0 to 1500. Data field. This contains the actual data that the frame contains. Pad. Okay. Valid frame must have 64 bytes long from destination to checksum. If the frame size is less than 64 bytes, pad field is used to fill out the frame to the minimum size. Checksum. It is used to find out the receiver frame is correct or not. CRC will be used here. So, other Ethernet network, switch Ethernet network, fast Ethernet network, gigabit Ethernet network. Switched Ethernet, that is 10 base T Ethernet, is a shared media network, and the entire media is involved in each transmission. The hub used in this network is a passive device. In switched Ethernet, the hub in this network is a passive device. So in switched Ethernet, hub is replaced with a switch. So in switched Ethernet, the hub is replaced with switch, which is active device intelligent, fast Ethernet. So there is a different kind of Ethernet: switch Ethernet, fast Ethernet, and gigabit Ethernet, to transmit data at highest frequency, to transmit data from one system to another system at highest speed. This is 100 base X. Okay, digital transmissions, 100 megabit per second, and 100 base underscore TX, 2 pairs of UTP or STP, and 2 optical FX optical fibers, and 100 base 100 megabit per second T4, 4 pair of UTP. So that is a fast Ethernet. So this is 100 base X, TX, 100 base X, compared to splitted into 1 TX and FX, UTP, STP, optical, and 100 base T4, 4 pair of UTP. This is fast Ethernet and gigabit Ethernet. 100 base SX, optical fiber, multi-mode, 100 base LX, multi or single mode, 1000 base CX STP, 1000 base T UTP. 802.3 frames do not have priorities, making them unsuited for real-time system, in which important frames should not be held up waiting for unimportant frames. A simple system with a known worst case is a ring in which the station takes turns sending frame. If there are n stations and it takes t seconds to send a frame, no frame will ever have to wait more than nt second to be sent. Broadband coaxial cable, okay, logical ring. Coaxial cable, these are the system 17, 14, 20, 7, 11, 13. Okay, so there is a logical ring. In logical ring pattern, so it is organized. So there is IEEE 802.4 is a token bus. 802.3 frames do not have priorities, making them unsuited for real-time system in which important frames should not be held up waiting for unimportant frame. So 802.3 it will not be suited for real-time systems. So a very simple system with a known worst case is a ring in which the station take turns sending frame. If there are n station and it takes t second to send a frame, no frame will ever have to wait more than n t seconds to be sent. Okay, so here number is a seconds, 17, 14, 20, 7. So with that second period, it send a data. Okay, otherwise, next one it will sending a data. The standard 802.4 is described as a token bus. Physically, a token bus is a linear or tree-shaped cable onto which the stations are attached. Logically, the stations are organized into a ring. Logically, the stations are organized into a ring with each station knowing the address of the station to its left and right. When the logical ring is initialized, the highest numbered station may send the first frame. After it is done, it passes permission to the immediate neighbor by sending a neighbor a special control frame called tokens. Here highest framed number 20. This system is sending a data. Okay. After sending a data, next highest frame number token number 17. It's sending a data. So in token ring topology, each station begin a transmission by capturing a token. After capturing a token, it begin transmissions. Okay, so once it's sending a data, it receive all other station on the path. So whichever address is matched, only those system or station it will receive a data. Other system it will reject a data or frames. So that is a token ring method. The token propagates around the logical ring. It will be circulated on the path of the ring, with only the token holder being permitted to transmit frame, since only one station at a time holds a token. Collisions do not occur. Since the cable is inherently a broadcast medium, each station receives each frame. Each station receives each frame, discarding those not addressed to it. When a station passes the token, it sends a token frame specifically addressed to its logical neighbor in the ring, irrespective of where that station is physically located on the cable. It is also worth noting that when stations are first powered on, they will not be in the ring. So MAC protocol has provision for adding station to and deleting station from the ring. So at any time we can add a system into a ring topology, or we can remove a system from the ring topologies. So for the physical layer, the token bus uses 75 ohm broadcast coaxial cable used for cable television. Both single and dual cable system are allowed with or without head ends. Here frame control, start delimiter, preamble. That is a format. Destination address, source address, data, checksum, end delimiter. So next, network use distributed processing in which a task is divided among multiple computers. So, advantage of distributed processing, security, encapsulation, distributed databases, faster problem solving, security through redundancy, collaborative processing. So, these are the different categories of work which will be splitted or distributed among multiple systems. In a network multiple system, it will take one security, distributed, faster solving, security and collaboratives. A single task is divided among multiple computers. That is distributed processing. Network criteria. Performance, reliability, security. What is performance? The performance can be measured in many ways and depends on number of factors. So network performance is defined by, measured by different factors. Number of users, type of transmission medium, hardware, software. So number of user is limited. At network speed, it will be increased. Type of transmission, fiber optic cable, coaxial cable is reliable ones. Hardware, highly configured machines. Software, software is installed. Network software, okay, and OS. So it should be used in the each systems. We can do any task in the network machine. Reliability, another second network criteria. First one performance, second one reliability. How you measure reliability? This is measured by the following factors: frequency of failure, recovery time. So a frequency of failure means if oftenly failure the network, so we cannot do any task. Okay, so the failure, it should occur rarely, rare phenomena. If it occurs frequently, there is no use of network. Recovery time of a network after a failure. One system is crashed, okay, or data is not sent. Quickly it should recover. Recover time, it should be shorter. Catastrophe, natural calamity. So it should not affect from the natural calamity. That is catastrophe, reliability. Security, unauthorized access. Network security issues include protecting data from the following. So network security means protect data. How we can protect unauthorized access? We can prevent unauthorized access. So how we can prevent unauthorized access? By assigning username and password. Okay, we can, every user, he has to log in their ID and password, so they can access. They should not share, they should not access another's data without permissions. Viruses. So virus program, it should affect their software or data. Securities. So these are the applications: accessing remote databases, accessing remote program, value added communication facility, marketing and sales, financial services, manufacturing, electronic message, directory services, information services, teleconferencing, cellular telephone, cable televisions. So these are the network applications. Okay, tomorrow we continue. Today in chat box you share, few students share mail ID. I will send a today notes to your mail. Few students share your mail ID. I will send today's notes. Yes, Kritika. Okay, it is enough. I will send to few of them. Please check it.
Sir, I didn't receive, sir.
You did not receive. Okay. I sent to few of them. Please check it. So, okay. Please leave the class. Tomorrow you come and join. All of you leave. Thank you.
Okay, sir.
Thank you, sir.
Thank you.
Thank you, sir. Thank you, sir.
Thank you.
Sir.